So there's another way that integrals can be improper. Notice the limit, there's no negative infinity for a lower limit, there's no positive infinity for an upper limit. There's another reason why this is an improper integral. What happens, there's a problem with one value of x inside the interval of integration. There's a 0 in between -1 and 2. So that's a problem. So what we need to do is split this up, like when we had negative infinity to infinity for our lower and upper limits. We need to split this up along those same lines to evaluate it. So the first thing we're going to do is rewrite this as two separate improper integrals. The integral from -1 to 0, which is it has to be 0 here, unlike when we split up the integral from negative infinity to infinity, because 0 is the problem child, right? And then of 1 over x cubed dx plus, what would the lower limit in the next one be? 0 to 2 of 1 over x cubed dx. And the idea is this definition, this is really a definition. This is how we interpret an improper integral. Now, in order for it to converge, both of these integrals we've created must converge. Okay? If one of them converges to infinity and the other one converges to minus infinity, you might think it's an improper or an indeterminate form, rather. No. By definition, both of these have to converge to for the integral to converge to a finite number. Which means if it doesn't converge, all you got to do is evaluate one of these integrals, and if it doesn't converge, you're done. You don't have to evaluate both of them. Okay? So, all right, I happen to know something about this that's going to make this problem a little bit shorter. I'm going to evaluate this integral first, and then if it converges, I'll go ahead and evaluate the other one. If it doesn't converge, I'm going to stop, because if one of them doesn't converge, then the entire integral does not converge. Okay, so now be careful here. How could I rewrite this? Remember, the offensive guy here is 0. So how could I rewrite this using a limit? Limit as b goes to, this is directional though. It's going to approach it from which direction? The left, so it's 0. It's a one-sided limit. Remember those? It's a one-sided limit. So that's the first time we've seen that today. So it's the limit as b goes to 0 from the negative direction of the integral from -1 to b 1 over x cubed dx. And then, plus ... but I'm not going to evaluate that other stuff right now until I know whether or not this thing converges. All right, so now evaluate the integral, find for me the antiderivative of 1 over x cubed dx. So this is kind of scratch work. That's the same as x to the -3. 1 over x cubed is x to the -3. So if you evaluate this, what do you get? Add 1, what's the new exponent become? -2, and then you divide by the new exponent? Or multiply by -1/2. Divided by -2 is the same as multiplying by -1/2. So maybe a better way to write that would be -1 over 2x squared. So I kind of found our antiderivative separately there as well. You can do it in line if you want, but it's kind of nice if it takes you a few steps to do it. It's kind of nice to do it separately. Is that okay? All right. So this becomes the limit as b goes to 0 from the left of, okay, the antiderivative, -1 over 2x squared. I'm going to write the negative on the outside. Evaluated from -1 to b. Do you believe that? No issues there? I don't know why I switched to black. I'm going to switch back to blue. Okay. And then the limit as b goes to 0 from the left, negative, okay, apply the fundamental theorem. What do we get inside the evaluation brackets? Oh, wait, it's b. The upper limit's b, right? We haven't evaluated the limit yet. So the upper limit's b, so 1 over 2b squared minus just 1 over 2, because the negative will square out when you plug it in. Everybody believe that? And then, yeah, there's other stuff over here, but we'll worry about that if this thing converges, which right now, is it looking like it's going to converge? Yes. Oh, yeah. Think about it again. What happens to the... Okay, what is 2b squared doing as b goes to 0 from the left? The denominator is getting closer to 0, so what's the overall value of the fraction doing? It's blowing up, guys. Right? When the denominator gets smaller, numerator stays the same. The fraction goes to, in this case, it will be positive infinity because it's 2b squared. So even though these are negative values that are, you're getting close to 0 from negative values, the denominator is positive, so it'll be getting close to infinity. But there's a negative out in front, so it will be negative infinity. Okay? So this limit then is negative infinity. If I'm not going to touch the other one doesn't matter. If one of them doesn't converge, then we say the integral diverges.